How does it find?
It's not I.
What about people with the exact same name?
Huh?
That's really odd.
They're barely any.
All right, so we're solving this question 8.
That's where it's from.
Question 4 from 2008.
It's the other way around.
Oh.
Do you want to let us in on the secret? So we're trying to find the biggest prime factor of that, right?
Yep.
And then you factorize a 7 and an 8 out of it.
Yep.
Just a bit slow on the 7. No? Yeah. Yeah?
Yep.
And then we don't care about those anymore, so we're looking at 7 to the 12 minus 1, which is the difference of 2 squares, yeah?
Which is sum and difference of 2 cubes.
Yes, that's key, right? We talked about that. They didn't learn this at school or something.
Oh, when did they learn that? Like 9, year 8. Oh my God.
Well, Leo did from his school.
Yeah.
How school's that?
You should be better.
Okay, so you got there.
Just like the best school.
Guys, you're on. Anyway, so and then difference. Oh, did you do
I did.
difference of square? Why did you do difference of squares?
It
Oh,
was 765, but then it
oh,
was.
that's probably better. Yeah. Yeah.
Do you see how that works? Yeah.
So,
That's
that's like.
And so this is kind of like, yeah, it's algebra, but you have to realize it's algebra. Yeah.
So we don't care.
It's 7, even though it's like you're used to x, but it's 7, right?
43. So this might be it, but we have to check that one first.
We got 43 as well.
Yeah. So then we just have to basically check 7 4 minus 7
yeah.
squared plus 1, right? That's yeah.
So,
So we can erase everything,
yeah,
and if
so
it's
that's-
not bigger than 43, that's the answer.
Yep.
And if it is bigger than 43, so okay, so right.
Yeah.
Oh, you already times it out.
That's the thing. Yeah.
He times those out.
We don't have to times it out, I guess. You can
Hey,
just
you already
divide
went
it straight away.
255.
But yeah, like,
Oh, yeah.
255 something.
but yeah, I mean, there's nothing wrong with times.
Just divide 2, 3, 5, 3, 5, 13.
But like,
Okay, so
you
you're
know it's
saying
not
this
by 7.
number is 2353.
Yeah.
It's not 7.
You said it's divisible by 13, right?
Obviously, it's not 7, and it's not by any other
Yeah.
obvious thing.
So
So you
not-
try 13.
So it's not
I mean,
divisible by
like, we're looking for something greater than 43, but we have to get rid of that small stuff first. So that's not divisible by 9.
yeah. So anything that divides 7 squared, 7 4 minus 7 squared does not divide the whole thing.
Yeah. So that's like, try stuff like.
So he said 13 is
13
divisible, yeah.
Yeah,
So
11
yeah.
doesn't work as well, because yeah.
Yeah. Okay. 13, 1. You lied to me.
Didn't they say 13 work?
Yeah, it's 181, not 19.
Is it? Okay, I thought it was 11. Sorry.
Yes.
105, 104.
1, 8, and 1. That's 8.
It's a 1.
Yeah. I guess once you said it's 181, you could do 181 times 13.
Yeah, 1. So now it's a 181. So then,
And 181 is
Oh, yeah.
It's not divisible.
7.
Oh, yeah, well,
Thanks. It's not divisible by
like,
3.
Yeah, we only need to check for like. So we only need to check up to like 14, right? So
Yeah.
clearly no 2s, no 3s. If we try 7. Since we only need to check up to 14. Oh wait, yeah, okay.
Yeah. I mean, we already knew it wasn't any. Well, okay. You're not, okay. I thought you were. I thought he was writing the factors that weren't in there, but it's actually the number.
fine.
We didn't
So-
check 181, we just say that it's true.
You didn't check it
we
was
did check,
prime.
we did. I checked.
I did.
Alright, so like 13.
Why would you
13.
check?
You just have to check 13,
So,
11,
no,
7,
doesn't work.
5, 3.
11, we tried the
2.
rule, it doesn't work. 7, we know it doesn't divide 7.
No,
So-
wait, does it?
It can't be.
Oh, yeah.
Yeah.
So
Unless
therefore,
it does, then you will know.
this is fine.
Yeah, but you might want to check it directly because now you have an answer, right?
Yeah.
Just check it's prime and check it divides the original thing directly. You could do that, right?
Yes, fuck out the original thing.
Yeah, but I guess, yeah,
I want to write the whole thing up.
you didn't. But it was only worth 3 marks, but only like 10 people got it, whatever it was. All right. So the other question, maybe I'll go.
Yep, okay.
Have you done this question?
Maybe.
y to the y. I can go through it, but I don't know if you want me to run it for you.
Sound like a fun question. Let me try.
Okay. So that's that one. Okay, well, while you try that, then we can try the cell one, yeah?
Yeah.
Okay. And then we'll meet at the board.
I'll do both and then.
You can do both, yeah.
Yeah. And then this let's do this one.
Where's a pen? Is that your pen? Why do I never have any pens? Oh, I've got a pencil.
It's a bit of a good question.
Yeah. Oh, did you figure out the floor question? Did you read my email? Oh, actually, it wasn't that. Well, that was just a hint, but most people just ignore the email, actually. So. Okay. I can go over that too. Actually, Leo can go over that. The floor question. Okay, I'll go over it.
Oh yeah, Michael. What time we finish? I didn't miss.
Oh yeah, me too. He doesn't know.
Can you guys stay till 9:30?
Sure.
9:30?
Sure.
9:30. Probably I'll just tell my friends.
Okay. Yeah, it's getting a little late.
Start like a 2 hour class.
Yeah.
On Monday, maybe we can finish a bit earlier, so like I get a bit more sleep before.
Yeah. I think you can even we'll organize it for you.
What do you got it?
Because I don't think you should like do a normal day on Monday because it's kind of pointless. It's
Yeah.
more important to have a rest.
Yeah.
But yeah, you can come and we can do some last minute checkups.
Wait, we end at 2:30.
Yeah, we do.
Yeah, we can come early, Michael. We end at 2:20. I'll meet at 2:30.
Let's go into 3 and 6.
So
Just
why
early.
06?
What about like?
Just cause.
I mean, why not like?
But I guess 105 is like a plus or minus, 30 seconds or something. But 06 it's like 05 it could be like, I don't know what it is, plus or minus 2 minutes. 06 is like, there's no room for error really.
But at the end of it, you want to get the whole grid to be 0, right?
Yeah.
Yeah, it's not possible. It's not possible.
Pretty sure it is.
Anyway, so when you get the XY question, we'll do that on the board and then we'll continue with the cell question, yeah?
But can numbers in a row be the same?
Yeah.
I have to make it so anything can be fine.
They will work.
is y to the power of y over x equal to 1.
Y to the power of y.
No,
Over
because
x.
you can't.
Equal
If
to
you divide x to the power of 5x over x, it doesn't give you. If you divide x to the power of 5x over x, it doesn't give you 1. It gives you x to the power of 5x minus 1.
Okay, all the way around. Wait, is root of x to the power of x to the power of x on 2 or
No.
x on 2 to the power of x?
X to the power of x.
Yeah, thoughts.
Wait, what?
Now just equal to this.
Yeah, it is. I think so. He says it's
X is equal to y to the power 0.2.
How?
The x to the power of x is equal to y to the power of y on 2, y on 5.
No, I just rooted both sides.
Yeah.
So x to the power of 2.5x
Yeah.
equals to y to the power of y on 2.
Why do that question after you?
And then
As you can you can't divide the y and x out. Yeah.
Why it's not the same?
Wait, what did I do?
What did you do?
What did I do?
How did you do that? So how are you going to calculate root 5s?
Hmm?
How are you going to calculate them? Yeah, root 5. This is root 5.
That is,
Yeah, it is. 0.2. 105. Is it x must be that small? Yeah, it's small.
wait, what? Root 5 is 0.2.
Yeah, y to the power 0.2 equals to y to the power 105.
Or y to the power of 0.2. Root 5. Oh, no, this. It's x and, okay, x to the power of x equal to y to the power of 0.2y.
Yeah.
If that's useful. Would you do that? It's good. Huh? What? Y to the power of x is equal to x to the power of 0.2y.
Yeah. Wait, what?
What it says by x and y.
Y, okay.
So then you put over y. So the power of x. 1 of x to the power of 0.2y. and then
Well,
Did you get an answer? What? Did you make progress on the cells question?
no.
Try it for like two numbers. Because can you see basically the basic
How do we wave it? Multiply by 200
so it's 1 on 1.
That's
Yeah.
To the power of x minus 1.
so the problem is it's too hard to think about 2016, right? But
Oh,
I think the
come
problem
on.
basically reduces to thinking about two, a column of two. If you can do it for a column of two, I think you can do it for the whole question.
Is it column of 2? Two here, one, two.
But just try it with two numbers, yeah? Like, I'll give you like 1 and 5, yeah?
Okay, from 1 to 5, you can double it, minus 1 for both sides. So it's
Yeah.
1 and 4.
1 to 5. Yeah.
Wait, when it says double, right, do you double every single row or just that particular row?
Just that row.
Wait, so then can't you just go like this? 1, 5,
Yeah,
double it, 1, so 2, 5,
yeah,
minus 1 from both sides, so 1, 4.
yeah.
Double 1, so 2, double 1 again, so 4.
Can you explain what you did? So you got 1, 4. What did you do?
Double 1, and then double 1 again. Oh, double.
So you got 4, yeah?
Yeah.
Yeah,
Minus 4.
that would do it for 1 and 5, yeah?
Wait, so for any number, can't you just minus it to like one number? Just one number being 1, the
Mhm.
number being something x.
Okay, so you're going to assume one of the numbers is 1, right?
Then you can minus it until it's
I
1.
asked if I forgot to solve it. I forgot how to solve it.
This one.
Yeah.
Oh.
I don't know the answer to like.
See, I did it on Wednesday, but I just forgot it. What is it? 5,000. No, why is 5,007?
Well, don't give it away, solve it.
Oh.
Wait, that's a bit bigger than 999. What is
It's not 5 to the power of 7.
Asking for x, right?
It's asking for x.
Oh, x is what do you call it? 1, 2, 3.
Well,
The largest town.
stop revealing it. Wait, do you care or do you want to?
Yeah. Just look at the answer, so don't think we can.
I wouldn't like.
I can just tell you.
Okay.
Right.
That this actually don't tell me.
Oh.
Yeah, wait, so for the grid one.
I tried to respond.
I mean, but this is the thing that where we came up with on Wednesday was not in the back of the book.
Oh,
But it might not even actually be a proof, but it's like proof enough for the AIMO without, like, it was only answer only as well. What were you saying?
So
So you can assume one of the numbers is 1, yeah?
you can get it down to 1, yeah.
And then the other number's like,
X, whatever.
what are you doing?
You
Oh,
can,
and you can always get it too.
it's basically a
Wait, no,
binary thing. I mean, yeah, binary thing. So you can make any number, just double it.
So you double it, yeah? And then what do you do?
So,
So you got 1 and 20. What do you do?
you get 1 and 20.
Hmm.
You keep talking.
You double it until, let's say, 16.
16, okay.
Minus 15 from both, so 1 and 5.
1 and 5.
And then do it.
Okay, so the number keeps decreasing.
You go to the nearest one and then make one side 1.
Mm-hmm.
And that's how you do it.
Yeah, so what does that mean? So you
that is
keep,
possible. Well, only for 2 things.
yeah, so your way of doing it is you take the smaller one and you minus it until it's 1, right?
Yeah.
And then the other one is something bigger than 1, yeah?
Yeah.
Okay.
Double the first one until it's like the closest one to the
Yep,
whatever the number is.
yep.
Then minus both sides until the smaller one is 1.
Mm-hmm.
and then it should be small enough.
So it keeps getting smaller and smaller. And do you know eventually it'll become like 2?
Not necessarily 2. I mean, we didn't solve it when it became 2.
I can't tell if this is a legitimate enough like way of thinking.
Oh, maybe this is the right one then.
Okay. Because like it means that because I think that like x, the only x I got was like 1.
Oh,
Wait, is it legitimately bigger than 1?
yeah.
Okay.
But like, yeah, there's well,
Who remembers that?
So like,
yeah. So okay, the part of the solution was that 1 works, right? And it doesn't seem like anything works for ages.
Yeah.
You know? Do you want me to just go through it, or
uh,
I like the resilience.
I keep trying.
Okay, so now what's the next stage? We know 2 numbers work. If we
Maybe I
don't-
can talk about something while you're doing this. You can even listen, and then the others can be asking questions. Hey, do you remember that question with the floors?
Right.
So it was like A on P. You never did this question, did you?
Yeah, I remember that question.
Okay.
This is the one. Remember this question? Do you remember that question?
Yeah, I remember this is like very recent.
Oh, this don't.
It's like
This is the
Monday.
thing that we took
Yeah, one
3
Yeah.
hours on.
So basically, we didn't take 3 hours.
Wait,
on this.
PA on A.
This whole question.
Wait, why
on
PA
P,
on
on
A?
P, on P, not
Because it's
On
just like
P.
a personal thing.
On P.
Yeah, so basically
P.
on P. Yeah. Sorry. Why is
Otherwise,
this
that'd just be
pen?
P.
Another pen. Another pen. Thanks. Yeah. So.
Yeah, been
Basically, the point is we know it's actually this class in particular knows something about primes and their remainders, yeah? So like, this is the fact that's key. So when, see, P either divides A or there's going to be lots of fractions, right? So if P divides A, I'm sure it's just you take away the floors and it's equal, right? But if P doesn't divide A, then the problem is there's all these little fractions, yeah?
But it's floors.
Yeah, but the point is the floor, you don't know what the floor is doing because there's fractions everywhere now, right? Whereas if it divides A, you know exactly what the floor is doing. It's doing nothing, right? Okay, but the thing is you know what the remainders are, see? You know every remainder is different. Can you see that?
Yeah.
Yeah, so can you see that if if Ka has the same remainder as La, right?
And it's
Mod
being
P.
K plus P equals L.
Yeah.
Isn't K plus P equal L then?
No, so the point is that they all have different remainders. If they have the same remainders, then their difference is divisible by P, right?
Yeah, that's right. Oh. I
Yeah.
just said can't just K plus P
But
be
like,
equal to
then A
L?
has to be P and K minus 1. Oh.
Yeah, I mean the point is P divides a product and it's prime and it doesn't divide A, it has to divide K minus L, right? So whenever a prime divides a product of things, it divides one of them, right? That's a key property of prime. So if P divides AB, P divides A or P divides B. This is something worth memorizing. Okay, so if it divides this and it doesn't divide A, it has to divide K minus L, right? But K minus L is like, if that's a multiple of P, right? Well, the point is K and L are both less than P, right? They're both between 1 and P. So K minus L itself has to be less than,
P.
has to be less than P and bigger than 0, right? So the only multiple of P that's in this range is 0. So K has to equal L, right? So basically, none of these remainders are equal, yeah? But there's exactly p of them, isn't there?
Yeah.
So they must be all the numbers from 0 to p, 1 to p, or 0 to p minus 1, yeah? Does that make sense?
Yeah.
So like we don't necessarily know what order it is, but we know that when we add it up,
Can you find that out before doing it?
we're losing 1 on p plus 2 on p plus 3 on p. Does that make sense? Do you understand?
What?
So because all the remainders are different, there has to be one of each remainder in each of the terms. So then the floor thing takes away exactly
What if a
the
bunch
sum
of them
of
is 0?
They can't be, right? We just said they can't be the same. What do you mean a bunch of them? The remainder is 0. Oh, the remainder only is 0 at the end, right?
Because p has
Because
no
p
factors.
divides. The remainder is only 0 if it divides that, right?
No, because after the flow function.
What?
After the flow function.
After you take floor.
Mm-hmm.
Yeah.
Wouldn't like a bunch of them be like the same thing?
Yeah, there will be, but that's the point. It doesn't matter what they'll be. What they'll be is they'll be as if there's no floor function there, right? Minus this sum. Yeah. Because what does the floor function do? It basically kills the remainders, right? Yeah. So every time there's a remainder, it puts it to 0. Yeah. But the remainders are 1, 2, 3, 4, 5, 6, 7 up to p minus 1. So you might not know what each one of them are, but you know the total sum is going to be all the remainders over p.
So
Yeah?
what's the question? Like, what are you trying to find?
Find the values of a that makes
Can you ask this question at the start? Yeah, the question is this. Okay, so find all the primes p, right? Such that, yeah, so that's good. You've done the question. That's a good place to start. Okay, so find all the primes p such that there exists an integer a, positive integer a, yeah, such that a on p floor plus 2a on p floor. So these are all like going up by 1, all the way up to p. That's the question.
But the answer. Or just
So what is it?
that's it.
I just really one more answer from the answer we got on Monday.
Ah,
So we use the sum. So we
Half times a. If a is 2, more than a half times a will make it 1, right? Understand what I mean by that? Like if a is 2, right? And you times this by half, then it'll be 1, yeah? The floor of it will be 1. If you times it by like 1 point, like if you times it by more than a half, right? The floor of it will be more than 1, yeah? So if there's 100 terms more than a half, and a is 2, right? There's going to be more than 100, yeah? Does that make sense? And obviously if a is bigger, it's going to be even bigger. And a can't be 1 because, well, a equals 1 gives you basically 0 for every term, except for, yeah?
What if it's 100?
Huh? Yeah, I mean, it's like we've already done this like before, so you missed this, okay? But the point we're trying to make is, if you know p is less than 200, you can just try lots of p, right? Especially if it's not in the exam. But now we're in the time limit, we might have to find a better way, right? And I think the thing we're trying to notice is that when p is prime, okay, all these numbers when you divide by p are going to have a different remainder. Okay. That makes sense? So basically, the only way to get remainder 0, okay, is, and remember this is an example of that thing we're doing when we're powering to the identity. In this case, powering is time.
Yeah.
Yeah?
Mhm.
Do you agree? At least that's what I'm saying. If you want to know why, well, let's think if they have the same remainder, right? Suppose like 3a equals 7a mod p, right? So what does that mean? Well, it means 4a is equal to 0 mod p, right?
That means A is equal to 1.
Yeah, but all these numbers are smaller than p, so the a has to be divisible by p, right? But we know that a is not divisible by p. Well, we're assuming it's not divisible by p because it's easy to figure out what happens when it is divisible by p. Yeah. So can you see anytime you have some a times something times a equals something times a, then some small number times a will equal 0, basically. Yeah. And if that happens, it means a is divisible by p. Because p either, if p divides 4a, it has to divide either 4 or a. Yeah.
I'm going to try.
Okay. We talked the piss out of him. Anyway, so yeah. You understand this claim? These all have different remainders when we divide by p, unless p divides a. Yeah?
Yeah.
Because if p divides a, they all have remainder 0, right?
Yeah.
Um,
P divides A, you can get a bunch of stuff.
Well, if p divides a, right, there's no need for floors because these are all going to be integers, right? And then it's an easy formula to solve. Yeah? Okay. So are we on the same page now? So if p divides a, it's easy, right? If p divides a, then there's no flaws. That's an arithmetic sequence. And then it's equal to 100. We can find a formula and solve it. Yeah? Okay. If p doesn't divide a, I'm saying these all have different remainders. Yeah? So we might not know which each of the remainders are, but we know that when we add them up, they're the same. Yeah? The floor is killing the same amount of, like, we know what the floor is taking away from the sum overall. Yeah? It's taking away 1 over p. So it's taking away
1 over P up to
so it's taking away 1 over p
Plus 2 over P.
2 over p
all the way
plus
up
3
to
over p
P minus 1 over P.
plus all the way to
It takes away
p
7.
minus 1 over p. Yeah?
So that takes away P minus 1.
Yeah, over 2.
Yeah, over 2, yeah.
Yeah? So this is equal to p. Do you know what this is equal to? Other people?
Over p minus 1, 2 over p.
2p, yeah?
So it cancels, yeah.
There's p minus 1 on 2. I mean, the point is you can remove these these floor symbols as long as you subtract p minus 1 on 2. Yeah? And I don't think I should keep going because I think you should be able to finish that. So basically what I'm saying is this left-hand side is equal to a over p plus 2a over p Scheiße. Plus pa over p minus p minus 1 on 2. Yeah? And that's enough to solve the problem, easily. But I think I should leave that for you to do. Because you just said this to 100 and solve, right? So basically, you're trying to find all the values of p that make a an integer. Yeah? Or another way of thinking about it, you're trying to find all the values of a that make p a prime. Okay, so like, do you know how to add this up? So this is the same thing, right? But it's multiplied by a, and goes up to p instead of p minus 1. So this is, what is it? It's a over p times, like
1 plus 2 plus 3 plus 4.
p plus 1 times p, right? Over 2. Yeah?
Well, it's just 8 times 50.
So you can cancel the p's, and then you can cancel the 2's if you make it equal to 200, right? So it's a outside of p plus 1 minus p minus 1 equals 200. Okay, I'm gonna go over a little bit of that cell question then. Have you done anything in the cell question? I'll give you one step.
The one that with the 2 part.
Yeah. So can you see how to convert your algorithm?
Mile.
Yeah, into solving the problem.
Can't
So you
just say
basic-
the row is equal to.
So you're basically saying, like, you look at one of the columns, yeah, 2 of the entries. You keep subtracting it that one of them's 1 and the other one's bigger than 1, right? And then you keep doing it in a way that this keeps decreasing, right? Until eventually you get to 2. Is that what you said? Is that what you said?
Not necessarily 2. Like something like
You can decrease until you get like
that. Until a
How
power of 2.
Does it, how does it decrease?
How does it not?
Oh, okay.
Give me 2 numbers. 1 and
Give me 2 numbers.
You want
1 and 5.
we did that. Okay, so 1 and 5, you double 1.
So basically,
So
you keep doubling
Minus
one.
1, so 1 4.
Yeah.
Oh,
Double.
I mean, you can always increase. You can always increase one by.
So this
Double
number,
1
like,
and then minus.
basically,
The fact that you can't go minus is the problem, not the
You just need to choose the biggest one.
actual problem.
Yeah, so once you get one column to 0, then you do the other ones without affecting it.
yeah. So even with the third entry, right? If you get these entries the same, can you see how you can get the third entry? Yeah. So can I show you maybe a possibly a little more rigorous way to get these 2 columns the same, or like at least easier to write? So for example, you think about some numbers like 10 and 1, right? It kind of like, well, how does it work? You want to sort of make that difference. See, like if the difference is, say, 9, right? You kind of want to shift the difference so that one of them is like 9 and the other one's 18. You know what I mean? Or one of them's like, 8 and the other one's 16. Yeah? One of them's double the other.
No, but if you always have a 1, you can just double 1.
Yeah, exactly. So
And
the
minus
point
one.
is, you can always, so no matter what these 2 numbers are, you can always make one of them's bigger and the other one's bigger than half of it. Yeah? So for example, this could be 6. Yeah? So as long as this is bigger than half of it, the difference is going to be less than this number, right? So you can subtract stuff till this becomes the difference. Yeah? Does that make sense? And if this becomes the difference and then the difference is maintained, right? Then that's double,
Yeah.
right? So a way to write that is you have like so A and B, right? In a column. So without loss of generality, we say A is bigger than B, yeah? And B is bigger than half A, yeah? See what I'm getting at? So if A is bigger than B, B is bigger than half A, then you know what we're saying before, we're saying the difference is less than b, right? So we're saying b is bigger than a minus b, right? Okay, but that's true because that's the same as saying 2b is bigger than a, b is bigger than half a, right? You know what I'm saying? So you can subtract a minus b, so a minus b is positive, right? You can subtract a minus b, and b you can subtract, well, maybe not subtract a minus b. You can actually subtract, because b is bigger than that, you can actually subtract b minus that, right? That's a positive number. So b minus a minus b is positive, yeah? So you can actually subtract b minus a minus b. Yeah? But when you do subtract that, this number becomes a minus b, right? And then this number, yeah, this is slightly more straining.
Wait, B minus.
Can you see that this
B
is
minus,
twice that?
B
Two
minus.
A minus B, yeah.
Yeah? That makes sense? So then this is always double that. So you can always double this row next to get them the same.
What if for 2 columns you can just take the largest one, the smaller one and minus the 2 one, and slowly decrease all the way?
Yeah, so that's what he said.
Yeah.
Yeah, you can do that. I guess this one you can do one step. Well, you double the one till it's over halfway, and then you do one minus.
Yeah, yeah, that's kind of weird.
So you're doubling it until it's as close as possible.
No, I'm
And then-
saying, wait,
You are, aren't you? You're doubling it until it's as close as possible, and then you're subtracting all of it but one, right? This is you're doubling it until it's over halfway, and then you subtract it and you got the answer. I mean, it's just a quick way of explaining it, I guess. Your way works too. You just have a hard time explaining. Yeah, so then you just have to double it, and then you have 2 equal row entries, right?
Wait, what I don't understand is, if you minus something, right? You have to minus from every single row.
Minus, no, just from the same column in every single row in that column. Not like the other entries.
Yeah, but then once a column gets to 0,
Yeah.
then you lost, don't you?
No. Once that column gets to 0, you're good. Because when the column gets to 0, you can keep going with the other stuff without affecting that column.
Wait, so if you minus stuff after one column gets to 0.
Because once one of the columns gets to 0, right? Yeah, like once the column gets to 0, timesing it by 2 is not going to affect it, right? And then all the other column operations don't have to be like they're done on other columns. The only things that will affect that column is that it's multiplied by 2. Yeah, so this is key because anytime you have 2 entries now, right? You can make them the same on a column. You know? So, and then the next step you could just make that column 0 if it was only 2 rows wide long, right? Then you can just continue on, yeah? If you have a third row, okay, well you can just make these 2 the same, right? And then it's as if you're working with 2 rows again, right?
you have to make sure not to get that third one.
Yeah, but you don't have to touch the third one, basically, right?
No, but you minus.
Oh, wait, Michael.
731, right?
Wait, so
And that's another thing why this process is kind of good, right? Because this doesn't change. This doesn't make anything negative. So you can do it to the last 2 things, right?
Okay.
So basically, this will make so these 2 like equal, right? and then you can repeat like as if it's just these two now.
No, but then once you repeat as if it's those two, and the first two is 0 already.
No, you don't make them 0. You keep them the same.
Oh,
You
keep
you,
them
you
same.
don't do the last step. You don't make them 0 because if you make them 0, it's game over.
You have to
right?
choose the smallest ones.
You have to. The last step is the one we make them all 0.
You have to choose the smallest ones. Otherwise, you might get.
Yeah, you choose the smallest ones. Yeah, that could help. Yeah.
Otherwise, you might get them negative
Wait,
or
and
interfaces of two.
Don't you want to like double that stuff? Because like what if like the minusing is like bigger than your number that you have the same?
Yeah, so you choose the smallest ones first.
No. What I'm saying is, at the end of the right, you know how you have like a small number.
Yeah. So one thing that's
So what
nice.
if like you're minusing from one number to get to 1?
No, we're not doing it.
That's
We're
what
not
we're
doing it
doing.
that way.
So the nice thing about this is that
You-
both these numbers are lower than the third number. Yeah.
Yeah,
They
okay.
never.
Makes sense.
It's quite a hard question too, huh?
Question what?
So
It's question 2. Oh God. Are you still solving the other one?
You have to know the answer. Yeah, sure. Actually, yeah. Okay.
I'll do the answer then.
Yeah.
But it's not an easy question. Actually, it takes a while to understand.
So x is 125, 5x is 625.
No, X is not. It's 125.
125 times 625 is equal to.
Isn't X 256?
I checked it.
So let's just do it. Okay. So basically, after staring this at for a while, we have so we know that X equals 1 works. Yeah.
Yeah.
And then pretty much nothing works for ages.
Yeah.
And then it's hard to explain this. So it looks like you want to pick something like X, right? And one of the factors kind of comes down
to make
to
it.
make it Y and Y.
Yeah.
You know what I mean? So in one sense, X should be smaller than Y, right?
Yeah.
And
So you got two numbers A and B that multiply to give 5x.
it's almost like Y should be a power of X. Okay. Anyway, so there's a lot of other thoughts that came in but didn't contribute to the answer. Like for example, all the primes that divide P, X divide Y,
Yeah.
and not only that, 5 lots of them divide Y, right?
Yeah.
Okay, so then there was this thing about considering whether Y and X are multiples of 5. I thought was interesting.
Yeah.
Okay.
What is that?
I think they do lead somewhere. It's just,
Maybe.
but the problem is I think that the extra rigor
Yeah.
that you get out of them doesn't pay off in this particular case. And the solutions at the back will be something to do with the primes dividing X and Y. Yeah. Okay. So for some reason, it felt like Y was a power of X. Okay. And if you try that, right? If you let Y equals X to the power of D, yeah. What do you get? So you get X to the 5X, yeah.
Yeah.
Equals
To the
X to the D to the power of X to the D, right?
yeah, which is d times x to d x to
Yeah.
yeah.
Okay. And then it's because the bases are the same, the powers have to be the same.
Yeah.
So 5x equals dxd, right?
XD.
So
And
that led to something interesting.
integers as well.
So what do you get?
XD.
So 5 equals dxd minus 1, right? Provided x is not 0 or whatever. Yeah.
So
XD.
And so 5 over d to the 1 over d minus 1 is equal to x. Yeah. If y is a power of x, yeah?
Yeah.
Okay. So I mean, so obviously, like, well, is it obvious that it's hard to gonna find. You're not really gonna find an integer power. D is not gonna be an integer, right? Looking at this, because all the integers you have to take some kind of square root of this, and so like,
Oh God.
you know what I mean?
Yeah.
Like fourth root, if it's 5, that'll
Yeah.
make that an integer.
Yeah.
But who said D had to be an integer, right? Maybe we can try D as a rational number. Yeah. Yeah. So if you do D is m over n, right? You get 5
And on them.
n on m, right?
Yeah.
And this is
1 on.
yeah. So it's n on
And minus n.
m minus n, yeah?
Yeah.
Equals x. And we want it to be a positive integer, yeah?
Yeah.
So one way, so there's not that many ways that stand out, is there? Like, so if you have a rational, like if you have a number that's definitely not an integer to some power,
yeah,
it's kind of unlikely it's going to be an integer, right? So one obvious thing you could do, and you can't make n and m cancel because you probably already picked them to be GCD1, right? Yeah.
Yeah.
But you can make m and 5 cancel, right?
Yeah.
You can make m and 5 cancel. So you can make it m equals 5.
Yeah.
And then you have n to the power of so m equals 5. And then this is
N to the power of 5 minus
n to the power of
okay. Yeah.
n on 5 minus n, yeah?
Yeah.
Okay. And can you see that, like, this, you need n to be 4,
4, yeah.
or like,
Yes.
it's going to be difficult.
Yep.
Yeah? Or something easy is n equals 4, yes?
Yeah, yeah.
Okay. So then this is equal to 5 over 4.
4 over 1. A.
So that gives you, what does that give you though? Oh, I shouldn't have erased that. Sorry. So 5 over 4.
Oh,
So this is
yeah. So that's 4.
4 to the power of 4.
4 to the power of 4.
Yeah?
Yeah.
So it actually works.
That's 16. Yeah, no, 16. 256 to 5.
Yeah.
What's that make it equal to?
Wait, what?
So it was
4 to the power of 4 to the power
4
of
to
A.
the power of
4. Wait.
4 to the power of 5 times 4 to the power of 4, right?
Yeah.
See, the point is the 4 comes up the top.
So it's 5 times 4 to the power of 5.
4 to the 5, right?
And then the other one is, yeah.
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 So that works, yeah?
Yeah.
And so, but actually, if you look at the original equation, so the question is y actually a rational power of x, right? And if it's the only solution, it has to be, right? So, but the thing is, yeah, it is a rational power of x, isn't it? Yeah.
Yeah. Okay.
What?
Oh, okay. Yeah. Can you make some y integers?
Yeah.
Okay.
So actually, yeah, like you try to prove it's a power of x first, right?
Yeah.
And it is, and then it just happens to also be a rational power of x. So I wouldn't say it's completely rigorous because it's really hard to justify that these can only be yeah.
But like 4 is probably in this case what? Because you want something simple for it.
Yeah, you want something convincing
Yeah.
to get the right answer, but you don't need a proof. Yeah.
Yeah. So
How
it's
do
maybe
you
the y
answer
term. Yeah.
Huh?
What does the question ask?
Largest.
Largest.
Yeah, how do you know it's largest?
Well, I mean, we're pretty convinced it's the only rational power that works. Yeah. So actually, the solutions are basically 1 and 256. There's no other solutions. Yeah.
Hey, so.
No.
But x and y are not allowed to be equal, right? X and Y are not allowed to be.
No, it doesn't matter. You can't-
It doesn't matter. Yeah.
I just think you can
And
get.
zero.
Yeah, they're equal when there's 1, but then
Oh, this- yeah.
then what X will be always smaller than Y.
You would minus 1 would work.
I think it's.
So it has to be positive.
Yeah. But you want the largest number.
Yeah. But yeah, we wouldn't be thinking about X equals 0, Y equals 0.
Destruction.
If that's like the smallest one, that'd be really sad.
Largest. That's-
That'd be, I mean, oh yeah, largest. Smallest one would be minus
You just
1.
give it an impossible equation. And you just transfer it.
Yeah. So do you understand the grid one? The grid one? So basically it's
Yeah, I
an
understood the grid one.
Basically, it's simplified to just one row turning to 0 because you multiply that.
So if you have like 500, right? And you have like 20, yeah? You can keep timesing this by 2 until it's over halfway. Yeah? So for example, 20 times by 2, how many times will get you over 250?
20,
13.
40,
13.
40, 80.
13.
Wait,
You get 260.
are they not in the same row? So we need times 2.
No,
Yeah, they're in
doubling
different
it.
rows.
Oh,
So there's a
doubling.
row here,
Yeah,
right?
what do you think it
Oh.
was?
And there's
That's fine,
another row,
No,
yeah?
it's doubling. It's doubling. 20, 40,
So keep
80.
timesing this one, right?
Oh,
Until
just
this is over
2, 4,
250.
8.
Yeah.
So 16,
Oh,
32.
32. Yeah.
32, so 320.
So 2 to the power from 5.
What are we
So
doing?
5 tons.
5 times 2 to the power 5.
Just 5 tons. 5
You
tons,
get
5 tons,
50.
5 tons.
What are we doing? Isn't it
Oh, 2 to the power 4.
4, yeah?
Yeah.
So then you get
2 to 0.
320, right? So it's over halfway, yeah? So the difference is now, what is it, 180, yeah? So the difference is less than this, right?
Yeah.
So you get minus 180 now.
Minus 180. Yep.
Wait, don't you minus?
Sorry, no, you minus it to make this 180.
Yeah.
So you minus whatever it is to make this 180, yeah? So then you make this into, see if you, to minus this to get to 180, you minus 140, right?
Yeah. So that one becomes 360.
Like 180,
and 360.
and this one becomes 360.
And then you double the bottom one.
Very
Yeah.
And you double the bottom, yeah? And any other ones that are bigger stay bigger, yeah? Okay. And then this way, these two are the same. So you can just do the same thing to both of them to get them the same as the third one.
Yeah.
Yeah?
And you only need to do for 2 because if you can do for 2, you can do the entire row to make it into
Column,
0.
yeah, and then once all the
And
columns
once you
are the
once you have
same,
a row is
you can minus them all at the
once you
same
have the
time.
column is 0,
And
then
now
you can
you just have to do the same for every column.
And then you just do it's now it's a smaller rectangle, smaller grid, right?
Answer is yes.
So the answer is yes.
I told you.
but just writing yes wouldn't get.
Yeah. It'll give
So
you
we were
one
saying
mark.
if yes, we give you 1 mark on the whole.
Why
Which is-
not?
So like, yeah, this is a pointless
Oh, you
debate
have a
though.
50% chance.
One wouldn't even give you yes wouldn't even give you.
Maybe.
Alright, well, do you want to all like have? So that was a little bit unfair because we thought about some polls at different times. Maybe we can all do one together. Huh? So do you want to go easier than that
Easier.
or harder?
I don't mind.
Because there are a lot of easy. If your easy problems are scattered, you should probably look at them anyway.
Yeah.
So this is a good time to do it. Yeah. So I was thinking we could do 1.
Oh, on that one. On
Yeah,
2016.
Were you here when we were making that joke? It's like we were asking the question its rating.
No.
Oh, okay. I don't know.
Answered like you rate it.
They're like, which question is it? And I was like, are you just asking the question its rating to see how good it is before you do it? Yeah. So
Yeah, that was over dinner when we started it.
this is the question, okay?
I think I did it.
Oh, you
I
were done?
did it like but yeah.
Oh, you already did it.
I think so. Like
Maybe we can do the third one then.
that one, yeah, I was halfway. I partially did it, but I couldn't finish it. So
Oh, okay. It's a good time to
Yeah.
do it because you have to get something out of this. Okay. So show that any sequence of maybe you can choose 1 to 2. Yeah. The one is determine A, B, C distinct
Are you trying to oranges?
triples,
Integers.
No.
distinct integers,
no.
Yes.
such that x cubed. Oh, do you guys want some chocolate? I have chocolate.
Hey.
Yeah, spread the chocolate around, Hagen.
Oh, it's open. Oh, it's almond again.
Ax squared plus bx plus c equals 0. Yeah. That's first question.
Get rid
Two.
of your palm
Oh, it's
oils.
the third question.
Get rid of palm oils. You can see the fingerprints in the palms.
Okay, third question. Show that any sequence of 6 consecutive integers. So for any show any sequence of 6 consecutive integers. Oh, thanks.
Of course.
For any sequence of 6 consecutive integers, there is at least one integer in the sequence such that x squared plus 1, x4 plus 1, x to the 6th minus 1 is divisible by 2016. Yeah?
This is like that one time when the year is actually like significant.
Yeah.
Yeah, a bunch of times the year comes up.
No, but like
Because it's just like
the
average.
fact that the year after matters.
What?
And this one, the year after matters.
So take your pick, yeah?
Wait. So basically, we're solving the cubic.
Yeah.
Oh God.
Hmm.
I'm barely. We basically just finished quadratics.
So what? We basically just finished.
Quadratics.
Basically just finished sketching.
From quadratics.
No, quadratic, cubic.
What the?
Wait, you guys do polynomials in here? No, you're in
hell?
top class, right? You're in top.
Oh, that's why.
I've really done parabolas.
Huh?
I've really searched up quadratics. I did.
You know, you're in your grade in your class with
Oh.
Yeah. Sorry. You should do that maths.
And why is he in this class?
How many people in top class actually do maths? How many people in the top class actually do maths?
The other top class, the second top class, they do this in the math.
So if this doesn't look easy, you need more chocolate.
What?
Yeah, I want more chocolate.
I want more chocolate.
Yeah, there's more chocolate.
What?
You know what?
There's
No.
you want more chocolate as well.
Performance enhancing.
Chocolate.
I have more chocolate where that came from.
Big quantity. Yeah.
Hey, I got one piece. Hey, I still have 2 left from before.
Oh, by the way, so this suggests that when you do Tournament of Towns, you're taking chocolate with you,
Yeah.
okay?
Oh, that my friend does that, and like my friend who went to camp did that. Does that normally, and then
You sure up?
he came in the tournament of towns last tournament of towns. I think he came like second or first for the for one of them,
Oh,
and for the like O level, I think, and for he got second prize for UNSW.
oh.
So
So what kind of chocolate was it?
dark chocolate,
Was dark almond chocolate?
probably, yeah.
And how much did he take?
He take the whole line.
What? And he finished his
I don't know how he finishes this, but like,
Yeah,
he doesn't take the whole bar.
That sounds like a yeah.
Like a good
like
idea.
coffee flavored chocolate.
Oh yeah, that'd be nice.
Why?
Because
That's
you know,
just coffee then.
yeah, that's good.
Coffee and chocolate.
All right, so the daring people do question 3, the less daring people do question 1.
Hey, what if question 1 seems daring to you?
Yeah, it's
Oh, no, I'm just kidding. I'm not going to judge the questions by their ratings.
What?
Oh, did I say, sorry, such that A, B, and C are solutions of this, such that X equals A, B, C, satisfy.
Otherwise, there's a bit too many.
Otherwise, the question doesn't really, it's not doable.
Determine three randoms.
Yeah.
So X can be A, B, C, and it satisfies the equation.
Yeah.
Oh, you should probably change the coefficient.
So like
Huh? No, they're the coefficients.
A,
Otherwise,
B, and C.
you don't know anything about the question.
Oh.
What's that? X can be X can be A,
Yeah.
B, C.
Do you guys know about like polynomials, like the sum of the roots equals A and the product of the roots equals C and all that stuff?
What?
Do you know that? Oh, maybe that's a good hint. So like you know for quadratics, right? Like that's a quadratic, yeah. You get x squared minus like that plus alpha beta, yeah. They equal. So the two roots add together to get the minus of the first coefficient. You see that?
Wait, how'd you get minus alpha beta?
Yeah, I got plus alpha beta.
Alright, in the middle.
Yeah.
Yeah.
Well, it's minus. It's x times minus beta plus minus alpha times x.
Yeah.
Yeah.
Oh, okay.
So the coefficient of x is minus the sum of the roots, and the constant term is the product of the roots. Yeah. So the same thing is true here. So the sum of the roots, so alpha plus beta plus gamma, is equal to negative a. Product, the negative of the product is equal to c, and the sum of the roots two at a time is equal to b. Yeah. Does that make sense? You get that from just multiplying. So
Isn't it like the sum of the sum of the two roots is like minus B over C?
yeah, that's if there's something here, but there's nothing here yet.
Oh, no.
Yeah. Because there's something there, you just divide it by that. Okay. But if it's 1, it's just the b. You know, like if you have a cubic,
Minus gamma.
and you expand it, right? You get this.
X cubed minus
X squared plus alpha beta plus beta gamma alpha gamma x minus alpha beta gamma. Yeah. So this is always the sum, negative the sum. This is the two at a time, and this is the product. Yeah. I mean, it's oh yeah, you realize, you know that question with the complex numbers and this to the power of 6 equals 1?
Yeah.
The question didn't ask for you to find A, B, and C.
Yeah.
Just-
do that. So
Yeah. So you could do it.
whatever.
Yeah. Or maybe I'll go through that and
Yeah.
Does that make question 3 more tempting now?
Oh no, makes one tempting.
Huh?
Makes one tempting. I just did 3.
wait, what?
I just started 3. I don't know how to do it.
Yeah, it is probably more.
But then he said that's a good deal.
Hey, Michael.
Hmm.
So in this, are you saying that alpha plus beta plus gamma equals to A
Equals minus A.
minus A?
'Cause
Oh,
it's
it's
minus.
minus. Okay. And then
Yeah.
alpha, beta, beta, gamma, gamma. Alpha.
Yes, I guess you have to discover the key to this question. There's just one real key.
Yeah. I remember trying. I tried it like a few days ago, and then like it was like kind of like annoying until like I realized like
The question.
yeah.
Yeah.
Wait, what does this mean? X equals to A, B, and
It's
C.
like I was gonna sub it in and like, oh wait a minute.
Yeah.
There's nothing to sub in. This must be like totally dramatic irony for you guys.
What?
Hey, what is C equal to?
C.
Yeah.
It's like an integer. Well, you mean this C here? The
Minus
beta,
alpha, beta,
minus
gamma.
alpha beta gamma.
What do you want to find then?
You want to find for which A, B, and C is A, B, and C a solution of this equation?
So minus A is equal to alpha beta gamma. B is equal to alpha beta gamma.
Wait, so if we, is it saying that if
So
we,
say minus,
if
yeah.
X is
yeah.
equal to alpha?
Oh,
yeah.
wait.
But alpha, beta, gamma are just A, B, C. Yeah. Because I'm saying for any, this is for any cubic polynomial with roots alpha, beta, and gamma, right? Then the roots were multiplied to minus C.
So all of them are positive.
Huh?
So they're all positive. So alpha is equal to A is equal to alpha beta beta. B is equal to alpha beta beta gamma. C is equal to minus.
Yeah. So B is equal to this, right? A is equal to minus this, and C is equal to this minus alpha, beta, gamma.
Wait, what? So it's the A is the same.
Yeah, so this A and this B and this C are the same.
That seems really dodgy.
Mm-hmm.
Because
And I guess I'm almost telling you that this is a good way to look at it.
wait.
No, I think I did.
Oh. Damn.
It's like one bash, but like special.
What? That's not special.
Alright, so let us know when we go over 1 then. Have we done 4? Flaws. Good old flaws.
Oh, geometry.
You didn't know it was geometry? So you managed to look at only definitely parts of the paper without looking at the whole.
Yeah.
Guys, do you want me to go through this?
Mhm.
Alright, good.
Nope.
Should just supplement it.
Oh, you could.
Wait, what? I still don't understand what it's. Is it saying that if x equals to
No, it's saying that A, B, and C are the roots of the equation. And the same A, B, and C are there. So
solution of the x?
Yeah.
What?
Huh? Go through it?
Yeah.
Alright. So basically we're using this thing, right? And that means A is equal to
wait. What am I doing? Never mind, go to
Alright. So you're gonna hit yourself when you say this.
I got this A squared A cubed plus A squared B plus A squared C.
Okay, so let me huh?
He's actually gonna hit yourself.
Yeah, you guys.
Hate himself or
No, I guess the problem is like
That's
if
it.
you- huh?
He wants to try again.
He doesn't want to hit himself.
Yeah.
Self-preservation.
I'm
I think the problem is like you don't know what to do with the result if you just learn it, so you might not be
Yeah.
comfortable with just
I
like
don't like realize.
that is the complete result. There's nothing more about cubics than that.
Yeah. But
So alpha, beta, gamma. Minus.
one? Just one.
So here you have to pick an odd number, right?
because
Yeah.
the
Yeah.
result is 2 to the power of 8.
And if you get an odd number, then pretty much the powers of 2s are taken care of, basically.
Yeah, all the
Yeah.
2's are.
yeah.
Then you just
And you just need the 7 and the 3s.
I think after you just do a few more cases with question 4, it's also pretty trivial. But you just have to prove it.
Wait, show any sequence with 6 consecutive integers.
Sounds like O level.
Okay, what's this? What is this?
So for any sequence of 6 integers, there's one of them such that this is a multiple of 2016.
wait. I factorized it wrong. Oh,
But if everyone switched to question 3, then I'm going to go through question 1. No, but like, I think it's a trade-off because the more time you spend on it, the more chance you want to hit yourself.
yeah,
Because at that moment, he'll definitely hit himself, but you may not want to hit yourself. But after you try it now, you'll both want to hit yourself.
But then I have to myself.
Wow.
then you feel this.
Yes,
Oh, amazing.
that's the attitude. Yeah, I like Leo. That's how I think. And then life gets long and you have a bad run of luck and it's constantly hitting yourself. No, but it doesn't happen yet.
Wait, any. What? Still trying to understand.
Answer to question 3.
Huh?
Answer to question 3.
What do you mean?
I switched to question 3. I'm perfectly fine so far. I'm fine so far.
Yes, you did. What if you didn't understand the question enough to figure that out? Like, I mean, understand the solution. Like a copy.
That's a weird answer.
Oh, are they still doing it?
Wait, Leo is.
Yeah, I'm still doing it.
Oh.
I need 6 numbers.
How can we use EFP?
Oh, because I don't want to use alpha gamma first. I just
Because
use
you're not
EFG.
fluent in writing.
Those are
Because I use the I have replaced this.
Oh.
And it's easier.
But aren't they the same?
Yep, it's easier.
So alpha is A, right?
Yeah.
Beta is B, and gamma is C.
Yeah, aren't they the
They're
same?
in fact the Greek versions of A, B, and C.
Aren't the roots A, B, and C?
Yes.
And aren't the square?
Yes. So that's the first step.
that could be important.
So A equals
I have a new
minus
piece of paper.
But you can
I don't wanna
reverse
look at my
perfectly. What?
B
So
equals
weird.
Wait, didn't we get that already though?
Yeah, that's
C
given to you.
equals minus A, B, C, yeah?
Can I have a new piece of
He-
paper?
Come on, the only one just realized that, but he's the only one that doesn't. I think if the other people know it, they might be able to do.
Can I have a
something
new
with
piece
it.
of paper?
Huh?
I don't want to look at my papers.
What? Is it unfair to put people under this kind of pressure?
I mean, it's true.
No, but which one do you decide for X? Like which root do you put as X? You put any?
What is that X equals ABC?
So, okay, if you see these 3 things, are you tempted to do something?
Yes.
What?
Oh, my calculus.
Which one?
Solve.
I mean, is there one obvious thing you can do right now?
Solve the quadratic.
Some one obvious thing. Like, no, I'm not even talking about like far. Just like the very first thing you do, like the first thing you write down right now.
Can you immediately do?
To ABC.
Okay, well,
No,
yeah, that's possibly the first thing. I mean, that
Yeah.
it's just because it came first. 2A minus equals B plus C, yeah?
Minus.
Plus B plus C equals 0, yeah? Okay. All right, good. What about the second thing? So I guess that was an example of like terms, yes? Like terms.
What do you mean 2A plus B plus C?
Oh, you just like
I just put the A on the other side.
you move everything to the other side.
Oh,
So 2A, B, and C, yeah?
ABC squared.
If you do this on your head, you might think the A is cancelled.
B equals A, C on the A plus C plus 1. Is it? Did I get something wrong? Oh, yeah, I did.
That's 2 plus.
Okay.
It doesn't necessarily need to be the second. It might be
Can you give that?
Oh,
much irony.
right, okay. Well, negative A equals 1.
Almost, yeah, basically.
Yeah, there we go.
If C is not 0, it can
Oh.
be cancelled, right?
Yeah.
So,
Divide both sides by negatives.
or C equals 0, right?
Yeah.
I guess that was the basic trick of the question. There was a possibility that C might have been 0.
I probably did miss that.
Yeah, so you gotta get
Yeah.
these 7 points. You can't leave them on the
Yeah,
table.
yeah.
Oh, wait, because C is in a root, so you can just see it's 0. Oh, okay.
Okay.
Oh, well,
Yeah,
okay.
that's that.
If C does equal to 0, it doesn't say anything, but like, you post, I probably still should write it.
Yeah, what happens if C equals 0?
So in the second equation, AB equals B. So A equals 1. And then
Or B equals 0. It's like, oh.
wait, does it say this thing?
Yeah, okay.
So,
It's like, yes, great reason.
yeah, because if B and C are both 0, and then A is 0 as well.
Yeah.
So,
Yeah.
so
they're all different, yeah?
Yeah.
So if C is 0, then they're both non-zero.
Yeah, so A is
Then
1.
A is 1.
Then B is, so from the top one it says B equals negative 2A, and B is negative 2. But the negative 2 times 1 is not equal to negative 1.
Oh, really?
Wait, 2A plus B plus C.
So there's no
is okay.
solutions when it's C equals 0.
Yeah.
Okay. Yeah, so by the way, in your AIMO, don't lose a mark like this, because that will make the answer completely wrong. So if you have no reasons, your 4 marks become 0, right? But if you have like reasons, your 4 marks becomes 3 marks. And if you just don't miss it, it's still 4
Yeah.
marks. Yeah?
Yes, if you miss, you get 0.
Well, if you get the answer wrong and you don't have a reason,
because you missed it.
Oh,
then it's wrong, yeah?
Yeah.
So you get 0. So Cavano gets 0. No, no, you gotta like write reasons for your answers. Then you only lose 1 mark.
Yeah.
But it's still too many to lose, yeah? For the time it takes to.
How did Hansel and this
Bad.
Wait, did you wait? Wait, why did you accept?
Oh, you drew.
No, because they were losing.
He told me you lost.
His team lost.
I said my team.
Like
You drew.
after 2 and 3, like after the other teams 2 and 3 won.
But they've already lost.
They've already
So then you just
the other
expedient.
guy just offered to draw. I think just.
But it was actually dodgy.
Yeah.
Like there was
So after
the board 4 draw was really dodgy because the guy just couldn't be bothered playing, so he like draw. Because like Kush is actually losing.
because for us,
It's just
like, after I lost and our board 4 lost, our board 2 won, and then their board like so so he was like 1,000 rated, and
Winston's 900.
yeah, and their board was like 900, nearly 1K. So it's a pretty cool, even match anyways. And then so after that, like
Hey, my match was not even.
Oh.
666 versus 860.
oh okay. And so then the other guy just the broker guy just offered draw, and then but like it was
Just,
like
like, no.
because like because she knows that she can't like draw because, and then like it's 45 minutes and 10 seconds each. It's just like an increment, but then like that guy ended up running out of time.
What?
So like it got to the point where both of them like not right like
How do you run out of time?
one person was on,
Increments.
he was on 22 minutes. He was on 2 minutes, and Evo was on 6 minutes. And then his one like slowly dripped down to like Evo was up a bit, and then he drooped down to like under a minute.
Hmm.
And then like one move, like and then he was looking and he was looking at the board for a bit, and then he glanced at the bait, and then like 4 seconds, so like he just like jumped and like made a random move. And,
How can you lose my time in an increment match?
like he moved it like like
Increments like each move you make,
yeah,
you get
no,
time.
like the he didn't lose time, but like he was on the
Get time.
You get time with them.
Yeah,
So,
and
like,
then
it
like
costs
he
10
ended up
seconds
like
every
wondering. So then eventually
You can go to like 2 seconds.
like one of the
You
moves
can,
was
you can go
he was
for
like
a
going
few
a bit
percent
fast. So one of his moves he accidentally like he knocked his king over by accident, and then and then like my board two guy just whispered like I said like might as well.
What?
Yeah, so whispered knocked over his king, and then William was like might as well. And then and then after the game he said that he wants lost on time in the 90 minute 30 second increment.
It's a 90 minute 30 seconds.
Okay, so yeah,
You get an
90
hour and a
minutes on the
half,
clock.
and you get like a minute basically every move. So
Oh,
you
yeah.
basically like
The half a minute.
every
Yeah,
game
half-
goes to move 20, right? So you basically get at least 100 minutes.
Mhm. And then
200 every 2 seconds.
So every move you get
every
30
30
seconds.
every time you press the clock you get another 30 seconds.
Yeah, time to your clock every move.
Oh, 30 seconds. That's only a little bit.
But to me, that's only a little bit. That's
Every
every
move.
move you make.
I know, but then if you're thinking that it's going to get
Yeah,
3
but
minutes.
like
But yeah,
But you
90
had 90
minutes.
minutes.
and once it
Oh,
reaches
so
40
you get
minutes, you get
another
another
minute.
90.
You gave half
Half
a
a
minute.
minute.
I'm pretty sure like after 40 minutes you get like more time.
It's like world
No,
championship
control.
match.
That's
Time
time
control.
control.
Time control.
Yeah,
Oh guys, it's time to hit yourselves, okay?
yeah.
Okay, so if AB equals -1, right?
And
Yeah.
AB are integers.
And AB are integers,
Oh,
there's not many possibilities, right? You can see that A, if it was 2,
Wait, A times B equals minus.
A times B equals -1, yeah?
So 2A times B is equal to.
No, A times B equals -1, right?
so I can be them 1.
So if A was 2, then B is already out of options. Yes? How can two integers times together to get -1?
One and minus 1.
1 minus 1.
Yeah, in both orders, right?
Yeah.
Yeah.
Why are they not hitting themselves?
yeah,
Why are they
Oh,
not hitting themselves?
dang, no.
it's
You
like
still don't understand the question.
They
It's
still
like-
don't get it.
you have to understand it to hit yourselves. That's what I.
I hear yourself, you don't understand.
Like this guy's sense of self-preservation runs deep. Yeah, I don't know. It's not completely obvious for some reason. Because when you're doing this normally, like you're not in this context of integers. So your first instinct might be to be like, oh, sub in there,
Yeah, I did.
sub this in.
I didn't know the 1 plus BC plus AC.
Yeah. Well, at least
And
I
one
mean,
equals to
did
A plus
anyone?
C plus-
Did you like when AB equals -1?
You didn't get
Do you sub -1 in here at least?
Yeah.
Yeah,
I mean, come on.
Okay, if you do that, then like
Yeah, that's forgivable.
but you don't get anything.
yeah.
Yeah.
Yeah, that's right. Yeah, no.
You don't see the A and B only have like 2 possibilities.
The fact that this was question 1 means that this like wasn't really like they were expecting people to get out of this step, I think.
Yeah, but no one's expecting this to come up. Though.
Yeah.
Like,
Because normally when you do these, it's like it's mostly like real,
yeah.
and then like that just happens and it's integers. So.
Yeah, I got the how to get from the normal ABC to the second part. And then I was trying to get the B. And then I was being retarded. I did A plus C plus AC over B.
equal to 1.
I was being retarded. 1 equals to A plus C plus
So,
AC over B. I don't know why. I was trying to get all 3.
alright. So what happens? So if A is equal to 1, B is equal to -1. Yeah. If that's the case, so we should go through it. Yeah. So if A is equal to, so A equals
Oh, yeah,
1,
and then
B
I
equals
should-
-1, gives you
C equals to.
C equals to -1, right?
Oh no.
C equals B.
Wait, C equals 1.
Alright. If A is 1, that's 2 minus 1 is 1, right?
Oh, yeah.
And then 1 equals C.
I'm confused.
C equals -1, yeah?
Yeah.
Okay.
And then I didn't know what to do.
Wait. Yeah.
Okay. And does that satisfy this one? So 1 times -1, that's -1, right? And then B, that's -1. That's -3. That's a contradiction, yeah? Is that -3? The BC is BC is -1, AC is -1. So that's -3, yeah?
So it has to be after.
The B is not -3.
Yeah.
Because it's -1. It's
So
1.
it has to be
Yeah?
Yeah.
So then let's try B equals 1 and A equals -1, yeah?
Yeah.
So that's minus.
That
So
doesn't
C
work.
equals
Zero,
1,
zero,
yeah?
zero.
C equals 1.
Mhm.
Yeah?
And then you get 1 plus. Oh yeah, you
So
get
you
1.
just try it. And
So that's -1 again here and +1, yes?
Yeah.
So that's what am I doing? So that's B is -1, yeah? That's another contradiction, isn't it?
Oh,
Unless I'm just making tons of mistakes. Wait. BC is 1, right?
it's is 1.
So that's 0, yeah? The B is equal to AC.
But
AC
it's
is
-1.
-1.
That's
right?
-2.
Where AC,
It's -2.
AC is -1.
Yeah. So then,
Where is
then
-3
B is
again,
not
right?
equal to -1, right?
Yeah.
It's equal to 1.
Where,
So there's just no solutions?
No,
Wait, hang
zero,
on,
zero,
no,
zero. Hey.
where go back again.
This
So like if A equals 1, B is -1, and C is -1.
Yeah. Then AC is 1, is it?
And then
AC is -1.
-1. Then BC is -1.
BC is 1.
BC, oh, is it 1?
Because B is -1 and C is
So
1.
BC over BC has not like
Okay.
B is equal to
So A equals
1.
1,
1.
B
BC
equals
is
-1.
-1.
C equals 1. And then
C
C
equals
is
-1.
-1.
Yeah?
And
So
then you
that's
get.
equal to 1, yeah?
This equals
One.
This is -3.
And then
Yeah,
S
it
equals
works. It works. It
-1.
works. This works.
Oh, so this works.
But undistinct.
B is -1. Oh, these are not distinct.
Oh yeah. Okay.
Oh. Because you can unhit yourself.
Yeah.
So there's nothing that works. I guess I didn't quite check C equals 0. Like we sort of did.
Oh, please. Oh.
Oh, it's a top one.
Oh, can I show? Do you want to go through this one? Oh, yeah, that's fine.
Okay, just try it later after we're done.
We have 10 minutes.
Huh?
We have 10 minutes.
You did?
No point,
Yeah, time goes pretty quick
especially when you're about to hit yourself.
when you're solving math problems. Yeah. All right, so let's erase that.
Let's do the second part.
I mean, I'll just explain this on the high beam.
I think you got this. Go explain.
What?
It was that complex number one. Actually, if I could just. Yeah.
I've got a thing tomorrow. There.
Yeah.
Wait, isn't that is sessions like weekly or something?
Yeah, actually, this is like this.
Every Wednesday.
Wednesday. Come on.
6:30 to 9:30. Oh yeah, 6 to 9:30.
It's just find the remaining.
Yeah.
That.
So you find everyone.
Yeah.
So that's A plus B.
Yeah.
Yeah.
I'm going to.
C has real coefficients. Not exceeding 2009.
I'm going to start.
So you have A plus B over 2009.
No, like Air Force cadets. Like,
yeah.
yeah.
You wrote that somewhere. Okay.
Yeah.
Not just marching around.
So that means both of them are
Doing
2000.
nothing. I was going to do it, except I
So A
didn't get
equals B.
Good thing I didn't
equals
get it.
2009.
anyone to.
Because they're not exceeding.
Like the
2009.
school.
Oh.
Turn, left, right, left, right.
No, I think that's it.
Oh, and then so
You
then
know what
once
C is.
2019, then you know what C is.
C is 2015.
Yes.
Oh, little Michael should have come back.
Yeah,
What's
I
scary?
was looking at your thing.
Oh,
Yeah, so that's 0.
Otherwise, I would have played.
15,
Oh.
and then
Okay.
Is little Michael coming back?
What are you
Music.
coming back?
like from his grandparents.
Oh, for like tomorrow and the day after, for like these videos, you'll mainly be doing like just standing there.
What?
So have fun. Like, standing
What a
there,
scam.
standing, like,
What's
doing,
this?
like,
Cadets.
He's joining cadets.
Why are you joining cadets?
Why are you joining
Ah,
Does it cost money?
160 a year.
Oh, that's
One-
pretty cheap. But like, quick,
140 a year if you pay early.
just do more maths.
But then you get and you get to go flying and stuff.
Yeah, that's why.
Oh,
I'm
But
doing
that
we get to play basketball.
when.
Sometime.
and
When I
you
think
get
you
to
need
shoot-
some conditioning.
You also get to shoot guns.
Basketball.
I'll take you to play some basketball.
Oh,
I'm better.
I started basketball.
We need-
basketball.
I can't.
Oh, do you?
Yeah.
At school?
That's one.
For sport? Oh, that's good. Basketball's fun.
I was going to ask.
Hey, for one of our sports is laser tag. Literally just laser tag.
Can I make an observation about
Do
this
they
question?
actually play laser tag though?
Please don't
Yeah.
fix this.
They
Guys,
do?
2 to the power 5 times 3 to the power 2 times
I wouldn't want to do that.
do we agree that this is 2 to the power of 5 times
3 to the power
3 squared times 7?
Oh yeah, it's 100 times 400.
Okay.
That's
So we need 2's, right?
But you always
So
going to
if,
get 2.
so if we pick even number here, we're not going to get any 2's.
You always going to get 2 if it's an odd number.
But if we get an odd number, we're going to get 4 2's at least.
400.
I did ask you.
Yeah.
Asking is fun.
Can I make another observation? X cubed plus 1. X minus 1. I don't even know if this gets anywhere, but I do all these
You
things
can
anyway.
just keep on
Huh?
like, can't you just keep factorizing?
I forgot
Yes.
the formulas.
So
We
X,
forgot the cube formula.
Yeah.
This is hitting worse.
I'm going to look it up today.
You just divide it.
Oh, look, there's 5. What is that, 5 or not?
Yeah.
X squared plus X plus 1.
Yeah.
So if you pick an odd number, you get at least 4 factors of 2.
you have a bunch of, wait, okay, you can cross,
Oh no. And
Did I miss
one
a
of
number?
these have to be 8-4.
Yeah.
So that's 8. That's 32. So that's 2 to 5.
That
wait,
makes sense?
why can't this become
it might. It doesn't
adding
matter.
of 2 squares?
It doesn't matter.
X squared. and
There is a
1.
thing about adding up 2 squares.
Oh, but it is, but you need like a complex imaginary numbers. Okay, so can you see what I'm saying? If you pick an even number, right, then all these plus 1s will be odd, yeah?
Yeah, so
And
they're
odds,
never
you're not going to get the 2's, yeah?
But you figure
Yeah.
odd numbers, you get even.
So if so if x is even, right, then all of these are even plus 1, right?
Yeah.
They're odd. They're not odd.
Yeah.
So they have no factors of 2's anywhere in there. So you're not going to get this 2 to the 5, yeah? So you need to pick an odd number, yeah? If you pick an odd number, then these will now all be even, right? And even means there's a factor of 2. So there's a 2 here, there's a 2 here, 2 here, there's a 2 there. So there's 4 2's, right? But we need 5, yeah? But actually, as Haibing pointed out, this, if this is not a multiple of 4,
Then that one.
then
X
this
plus
one,
is.
because these differ by 2, right?
Yeah.
So one of them has to be a multiple of 4. Does that make sense? If something's not a multiple of 4, you add 2, it'll be a multiple of 4, right? That makes sense, right? So one of these is a multiple of 4, so that's your 5th 2, okay? So then all you have to do is show that 3 squared and 7 divide all this, yeah? And I mean, if you're picking odd numbers,
I don't know. I can go and check. But like by then be
yeah, so basically we reduced the problem to showing any 6 consecutive numbers. We need to pick an odd number
That fits.
for which
This will become.
these are divisible by 3 squared and 7. Yeah, we already know it's divisible by 32. Does that mean you'd rather meet on Sunday instead of Monday? That's a bit
Wait.
too much fun.
Sunday? No, yeah, sorry.
Yeah.
Again, so wait, I don't know. Yeah, I think Monday's more still.
We'll keep it Monday, but we'll keep it like easy.
We can come at 2:30.
Like, because we can leave school early on Monday.
We leave.
Leave school on Wednesdays.
No, we
don't
leave
I
on
leave early on
Wednesdays.
Wednesdays. We do on Wednesdays as well.
Monday and
Okay, every second Monday for non-year 7s and every
Because year 7s have
PS
peer support.
and
Hey, peer support's okay. I mean, you got lolly day every week.
No,
basically.
well, this was shit. It's
Your peer support's bad.
I know everything about school's
What?
Nah, that's cool.
let peer support your kids.
Yeah.
You guys. Wait, still? Good.
I support was fun.
Yeah, that's what I'm saying. What's
Okay.
this
Like
guy?
only yeah,
Okay.
feel like, if you like people
Okay, we have Edwin and we
Edwin,
have Edwin
I
and
really went for the pizza.
Isabel.
oh
Don't you only play games? Talk
Basically,
yeah.
you make like towers and like
Then,
marshmallows.
I remember last year like a lot of the people I knew and then like so we went to like same primary school and then different overseas and then back to us and then we got into the same peer support group and then like they were like talking about I just want to play Mortal Kombat for like on his like phone and then it was like saying how like it was fine and it was fun.
Yeah, I mean, you guys maybe try some numbers. You know,
I'm trying.
Hey,
5, 6.
do play
think-
violent games.
He
Kiddo.
just like
Plays a violent
he
game.
just says to you like your
What time is it?
I'm trying
you want to watch a
to
fatality.
What?
You get fun.
Yeah, wait,
Yeah.
no, wait, I can
Stop
do
doing
this. I can do this.
Yes, you can do
Oh wait, remember that day when your dad came in?
Shut up.
Guys?
Wait, what?
The one where he's listening
Wait, what? What?
His dad came in 3 times.
To what?
Oh,
Oh, yeah, that was Nathan's fault.
Yeah,
Because he kept
keep pressing wrongly.
wait, what was he
Well,
pressing?
Well, I proved that if X is.
Oh,
Yeah, I proved that too.
what was
Because
he pressing?
X.
Oh,
Oh,
I'll
wait,
look at
no,
the
no,
video or something later. That's so funny. Wait, what was he pressing anyway? Is
No,
there
you
like
have to
a?
hold it down.
Is there a? Is
You
there a
just need to
recall?
press it once. Then
Is there a recall button? Like
No, you need to hold it down. My
Do you guys want to
just-
keep trying this, or should I be and reveal it for you?
Real.
I hope this is not the kind of resilience we're building up. Alright, I mean, tell us the truth.
So if you take. So that we know that it has to be some odd number. We know it has to be an
That's
odd
it.
number.
It's on number
Yeah.
then.
So, like,
could be
if,
one
let's take this example, right?
Yeah,
So
let's
which
take
number
this
would you pick?
example.
So it'll be either 3, 5, or 1, yeah?
Yep.
So,
So if we take something like, so if we take 3, it might be obvious that like these won't be multiples of 3. Like,
yeah.
so we probably have to take 1
You
of
can
5.
take one. If you take
Yeah.
one, then
So if you take 1, this becomes.
this become
multiple of
and the
and this,
yeah,
and
that
this one,
becomes-
right?
yeah.
Yep. Wait, is it?
No,
No, that
it's
one,
that one.
that
Yeah,
one.
yeah, because
So-
it gets through.
If you take, so this is showing what was this was x cubed minus 1,
Yeah.
and this was x cubed plus 1.
minus 1 plus 1 can no, they don't.
What
Yes,
are you
they
doing?
do. What do you
Okay, so if it's so if we think
That's
about it
fine.
in terms of 6, in terms of every
Wait.
6 numbers, right? There's going to be one that's going to be minus 1 mod 6, and 1 mod 6 in every group of 6, right?
So one with the remainder 1, one with the remainder 5.
Wait. Wait, is this?
Yep. And then so that means if it's if it's minus 1, right? Then that cubed is still minus 1, and then plus 1 you get the 3. You get the multiple of right. Okay, if it's minus 1, this becomes thing, and this is also becomes the thing.
Oh, yeah.
Yep. And so if it's plus 1, then this becomes a 0, multiple of 3, and this also becomes the multiple of 3. Right.
So what are we saying? If it's minus 1 or
If it's minus 1 mod 6, then
Yeah.
this part, both of these are multiples of 3.
that's 5 or 1, yeah?
Yep.
So we're not looking at the 3.
So we don't
No,
care
that's
about
the
3.
3.
So either one you pick,
Either one.
you're going to get a factor of 3 out of here.
You're going to get factor of 9. Because
Oh,
these are either like This
They're
is
both
gonna be,
good.
That's a factor of 6 or that's a factor of 6?
so if this is a factor of like, so if this is a multiple of 3, because like take 5,
that one is as
then
well.
this is so minus 1 squared is 1, and
And
then
then +1, then +1. You
Plus-
get 3.
like one of them.
Mine-
You take okay, so
So you
this
get like
and this together. Get,
so one of these give you a 3 and one of these give you a 3.
yeah,
What do we say?
yeah.
No matter what.
Yeah.
Because there's one of these will be
No,
0
I'm
mod
pretty sure
6.
it's these two.
Okay, so
Yeah, I mean, look. So if one of them's 1 mod 6, then that one's 0 mod 6, right? That'll
Yeah.
give you a 3.
and then one.
And
So
then-
1 more 6 1. Okay, then
Is that one? Is that?
Is that
1
one?
plus 1 plus 1.
Yeah, because that
that
give you 3 months.
Yeah.
Yeah.
And then if this is like minus 1, then this gives you 0. And this is
Yeah.
minus 1 1, and then 2 3. Yeah.
Yeah. That makes sense. So
So
in either
this
case,
7.
this is a multiple. Now.
7.
So now we do the 7 part. Okay, so basically,
so we've eliminated now the
Yeah.
even numbers and the 3
So
mod
it's
6.
only
Yeah.
one.
Yep. so it's kind of obvious that like if you have something like this, if it's a multiple of 7, it's not gonna work, right?
What?
So like if we have something of
If
this,
X
form,
is a
if
multiple-
X is a multiple of
Yeah.
7, there's no way it's gonna work. So that means
Oh, so we lose 1. Is that what you're saying?
the X is not X. We lose 7 basically.
Oh, but isn't 7 the 1? Oh, anyways. No,
So yeah, and then so basically that like okay, so if it's 1 mod 7, right, then X minus 1 is divisible
Yeah.
by 7, right? If it's 2 mod 7, then so which one was this one? I think. So X squared is 4
Yeah,
plus X plus
Plus
2
you get
plus
7,
1, so
yeah.
that's plus 1, and then 3 mod 7.
Is it
Well, I did check my sheet.
9 minus? Yeah, it's this one. It's x squared minus x plus 1.
Yep.
Yeah.
Yep, X squared minus X plus 1, right? And then 4 mod 7 is
I think it's x above.
is this one again,
Oh, okay.
because like so that's 16 plus 16 plus 4 plus 1, and then
Oh yeah.
5 mod 7 is X squared minus X plus 1, because so it's
Mhm.
25 20,
Yep.
21, and then 6 mod 7 is X plus 1, right? Because
Yeah.
so basically that means
So we missed out on 0 mod 7.
yeah, so 0 mod 7 doesn't work. So that means for as long as there's any like
Yeah, and picture.
as long as
That's
like
what it's gonna be.
like it's anything is basically divisible by 7. Like any number is divisible by 7 as long as that number itself is not divisible by 7.
This one will be divisible by 7 as
So
long as
this
the
expression
x.
Yeah.
will always be divisible by 7
Yeah.
As long
if
as
X is not divisible by 7.
Yeah.
And so like
Every 6 numbers.
in every 6 numbers there's a maximum of 1 number that's divisible by 7.
Yeah.
And since there's always 2 things that are
No,
there's
okay.
2 possibilities.
That
No,
give
like-
you all the other stuff.
So because it needs to be plus minus 1 mod 6,
Ah.
which gives you two options.
So,
And
so
then
if it's like if 7's any one of them, the other
If
one.
one of them is like
Yeah.
multiple 7, then the other one's
Other
not.
ones are not.
So say like
Eh.
35 doesn't work, then 36, 37 must work. So
Mhm.
37 must work.
So, that makes sense.
I can't
Yes.
I can explain it
I'm
to you.
pretty sure I
again.
can. I can.
Just lost. Just
Wait
a sec. What subject is this?
Oh, you're doing backwards.
But you guys do banking.
Yes.
What?
Yeah.
We finished
We don't
like
even
this.
have history.
Really?